Question number 10. In 3 moles of ethane, calculate the following. Number of moles of carbon, number of moles of hydrogen, and number of molecules of ethane. So first, the formula of ethane is C2H6. Okay, so in 1 mole of ethane, we have 2 moles of carbon and 6 moles of hydrogen, because the number of atoms of hydrogen is 6 over here, number of atoms of carbon is 2. So here first question is, we need to figure out how many moles of carbon is present. So if in 1 mole you have 2, in 3 moles you will obviously multiply it by 3. So 2 into 3, that is 6 moles of carbon atom or carbon is present in ethane. The next one is number of moles of hydrogen. So in 1 mole you have 6. Then in 3 moles you will have 6 into 3, that is 18 moles of hydrogen. We're just multiplying it. Okay. And the third one, we need to calculate the number of molecules. So 1 mole of ethane has 6.022 into 10 to the power 23 molecules, because that's the basis of our mole concept. So if 1 mole has so much, then 3 moles of ethane will have 6.022 into 10 to the power 23 into 3 molecules. So that is equal to 1.807 into 10 to the power 24 molecules. So this entire problem is based on mole concept. Here first of all, C2H6, that is ethane, has, when it is 1 mole, it will have 2 moles of carbon, because C2, and H6, that means it has 6 moles of carbon. So in 3 moles of ethane, we will have 6 moles of carbon, because we are just multiplying it into 3. So 1 into 3, 3. So 2 into 3 is equals to 6. Similarly, 6 into 3 equals to 18. So 18 moles of hydrogen is present in 3 moles of ethane. Not only that, 1 mole of ethane equals to 6.022 into 10 to the power 23. This is the basic thing of mole concept. So 3 moles of ethane will have 6.022 into 10 to the power 23 into 3 number of molecules. So, and when you simplify, you get this as the value. Question number 11. What is the concentration of sugar C12H22O11 in moles per liter if its 20 grams are dissolved in enough water to make the final volume up to 2 liters? So we need to calculate the molarity, because we've been asked about its concentration in moles per liter. Now we have been, let's write down what's given. Been given the mass of sugar equals to 20 grams. Next, we've been given the volume equals to 2 liters. Okay, molarity's formula equals to number of moles of the solute divided by the volume of the solution in liters. So the volume of the solution is 2 liters, right? So we need to first calculate the number of moles. Before doing that, we need to calculate the molecular mass of sugar. So molecular mass of C12H22O11 would be equal to 12 into 12, because 12 atoms mass, plus 22 into 1 plus 11 into 16, and this is equal to 342. So 342, we have the mass, so number of moles equals to the mass divided by the molar mass, that is 342. So be in grams, this is in grams per mole, so grams gets cancelled. So this, when it's simplified, or actually I'd prefer if we don't simplify this right now, we'll just leave it as 20 divided by 342 moles. Now we need to calculate the molarity. So molarity will be equal to 20 divided by 342 whole divided by 2, because you have 2 liters. And now when this is simplified, we get the answer as 0.029 moles per liter, because this is in moles, this is 2 liters, so moles per liter. So basically we calculated, we are supposed to find out the molarity, because we have been asked the concentration in moles per liter. We first calculated the molecular mass of sugar, and then followed by the calculation of the number of moles of sugar which is present, and then we just had to divide these two values up to give us the value of molarity of that particular solution. Question number 11. If the density of methanol is 0.793 kilograms per liter, what is the volume required for making 2.5 liters of its 0.25 molar solution? So we've been given the molarity, which is equal to 0.25 molar. We've been given the volume, that is 2.5 liters. And we've also been given the density of methanol, that's equal to 0.793 kilograms per liter. So we need to calculate the volume of methanol needed. Here this is the volume of the solution. So let me just make that clear. So volume of solution. So the volume of the solution which needs to be calculated is the volume which is required, the volume of methanol which is required is to be calculated. So let's start. First, formula of molarity is number of moles divided by the volume. So here we've been given the molarity, that is 0.25 is equal to the number of moles divided by the volume, that is 2.5 liters. So when we simplify this, we get moles of CH3OH, that is methanol, number of moles of methanol equals to 2.5 to 0.25. So that's equal to 0.025 moles. Okay, now number of moles also equals to the mass by molar mass. So the mass of methanol would be equal to molar mass into the number of moles. So molar mass of methanol is 32. Oh, I'm sorry, it is not 0.25, it's 625. We simplified, I'm really sorry because we are multiplying it. 32 into 0.625. Okay, so this is equal to the mass of CH3OH, that is methanol, is equal to 20 grams. Okay, so here first we are taking in the molarity equals to the number of moles divided by 2.5 liters. This simply gets multiplied with this to give us 0.625 moles is the number of moles. Then we calculated the mass of methanol. Now, as we have the density over here, the density is units, is kilograms per liter, which means in 1 liter of that particular solution, the density, or rather the quantity is 0.793 so kilograms. So 0.793 into 10 to the power 3 grams of CH3OH is present in 1000 ml, not liters, 1000 ml. So 20 grams of CH3OH is in how much? Okay, so this is equal to 1000, or rather I'll just put it here. So that's equal to 1000 divided by 0.793 into 10 to the power 3 into 20. We are just cross multiplying this, and this gives us a value of 25.2 ml. So this is the volume of methanol which is needed for making 2.5 liters of 0.25 molar solution. So first we were given the molarity and the volume of the solution. From there we were able to calculate the number of moles from the formula of number of moles. So number of moles equals to mass divided by the molar mass. Usually this is over here, that's how we calculate the number of moles. So mass of CH3OH can be calculated as molar mass into the number of moles, and 0.793 into 10 to the power 3 grams of methanol is present in 1000 ml. Then 20 grams of methanol will be in how much? So we just cross multiplied and calculated and found the value to be 25.2 ml. So 25.2 ml is the volume of methanol needed for making 2.5 of its 0.25 molar solution. Question number 13. Pressure is defined as force per unit area of the surface. The SI unit of pressure is, that is Pascal, is shown as 1 PA equals to 1 newtons per meter square. If mass of air at sea level is 1034 grams per centimeter cube, we need to calculate the pressure in Pascal. So we've been given the mass of air at sea level, that is 1034 grams per centimeter square, and we need to calculate the pressure in Pascal. So pressure is also defined as force per unit area, right? So pressure is force by unit area, that is here force is the weight, that is weight equals to mass into gravity, because the amount of that is the amount of force of gravity acting on a particular substance is given as weight. So pressure would be equal to weight per unit area, right? So basically combining these two, we can write pressure as 1034 grams divided by centimeter square, because centimeter minus 2 is centimeter square, into 9.8 meters per second square, second square. So this is nothing but the gravity, right? So pressure is, so now we need to find out the pressure in pascals, which means we need to convert all the units for us to get the units in terms of pascals, right? And we've been given 1 pascal is equals to 1 Newton per meter square. Okay, so we've been given 1 pascal equals to 1 Newton meter minus 2. We need to convert the units by using the method unit conversion, and this is done by figuring out the unit conversion factor, right? So first of all, 1 pascal equals to 1 Newton per meter square, and 1 Newton equals to 1 kg meter second minus 2. Okay, now as we know, the units will get cancelled to give us the final unit as pascals in the end. So we need to convert all of these in such a way that we can cancel all of them with each other. Okay, so first you have meters over there. Okay, so I'll do one thing, I'll parallelly write the unit conversion factor so we'll know what to do. Okay, so here 1 will be equal to 1 pascal divided by 1 Newton meter minus 2. So again, so this is in the denominator, which means we need the Newton to be in the numerator for the other one. So 1 Newton divided by 1 kg meter second minus 2. Okay, so now we have a meter over here, right? And we also have centimeter in this equation. So this centimeter square has to be cancelled. So 1 meter equals to 100 centimeter. Then 1 meter square would be equal to 100 square centimeter square. So 1 equals to 100 square centimeter square divided by meter square, because this will get cancelled with this. Okay, now we have kilogram in the denominator over here, which means we need kilogram in the numerator as well. So 1 kg equals to 1000 grams. So 1 equals to 1 kg divided by 1000 grams. Now, as per our unit conversion factor rules, we need to basically multiply the equation with all of these values. So 1034 grams by centimeter square into 9.8 meter second minus 2 into, first we'll go from the bottom, 1 kg divided by 1000 grams into 100 square centimeter square divided by meter square into 1 Newton divided by 1 kg meter second inverse into 1 pascal 1 Newton meter minus 2. Okay, now let's see. So here let me use another ink so it's easier for you to understand. So here you have centimeter square will get cancelled with each other. Kilogram will get cancelled with each other. Meters per second will get cancelled with each other. Newton and Newton will get cancelled with each other. Grams and grams will get cancelled with each other. Now here meter 1 by meter minus 2 equals to meter square by 1. So because of that, this meter minus 2 and this meter square will get cancelled. Now you need to focus, and now so you are left with only one unit, that is Pascal. So this is the basic idea behind our unit conversion factor, and when all these numbers are multiplied and they're simplified, we will get the answer as 1.01332 into 10 to the power 5 pascals. So what we've done is we've basically, first we figured out that pressure is defined as force per unit area of the surface. From that we understood that force is nothing but the amount of mass or amount of weight which acts on that particular, so weight acting per unit area. So weight is given as mass into gravity. So pressure, so we've been given the mass of the air, we've not been given the weight. So pressure would be equal to weight per unit area. So we had to multiply this value with gravity. Now we were asked to calculate the pressure in Pascal. So whatever answer we would have gotten here, you would have gotten the answer in grams centimeter per centimeter square, meters second square. So we had to convert all of these units to get our answer in pascals. That's where we started over here. So 1 Pascal is 1 Newton per meter square. And then 1 Newton equals to 1 kilogram meter per second square. So 1 meter is 100 centimeters. 1 meter square would be 100 square centimeter square. And 1 kilogram equals to 1000 grams. So basic idea behind unit conversion factor is these are all the unit conversion factors, and these will all be multiplied to give us the final unit in the end. They're all getting cancelled. One important thing, if you use the unit conversion factor, all the other units except for the one you want will be cancelled, and if it is not happening, then there is some mistake in between.